When performing a service upgrade on a residential property, understanding the utility's role and the necessary steps is crucial. Firstly, contact the local utility company. Inform them of the planned service upgrade. The utility will typically send an inspector to the property. This inspector will assess the existing service and determine if it meets current code requirements. Secondly, the utility will schedule a time to disconnect power to the house. This disconnection is essential before any work can begin on the service upgrade. After the upgrade is complete, contact the utility again. They will inspect the new service and reconnect power to the home. In most cases, the utility will upgrade the overhead feeders to the house as part of the service upgrade process. The utility may also perform necessary work on their side of the system. This work could include upgrading the transformer or installing a new meter base. Before starting any physical work, obtain the necessary permits from the local building department. This step ensures compliance with local regulations. After obtaining permits, the utility will disconnect power to the home. With the power safely disconnected, remove the old service entrance, meter, and panel. Then install the new service entrance, meter, and panel. Next, run new feeders from the new service to the main electrical panel. These feeders must be appropriately sized for the increased service amperage. Rewire the main electrical panel to accommodate the increased service amperage. This rewiring may involve replacing breakers and ensuring proper connections. Once all the work is complete, have the utility inspect the new service. After inspection, they will reconnect power to the home. It is highly recommended to hire a licensed and experienced electrician to perform the service upgrade. This ensures the work is done safely and correctly. Consider upgrading the electrical panel to a larger size. This will accommodate future electrical needs and expansion. Replace any outdated or damaged wiring during the upgrade. This proactive measure can prevent future problems. Notify the insurance company about the upgrade. This ensures proper coverage for the updated electrical system. When determining the size of the new service, consider the existing and future electrical loads. This includes lighting, appliances, heating, and cooling systems. Use the appropriate National Electrical Code (NEC) tables to calculate the load requirements. Table 310.15. B16 is commonly used for ampacity of conductors. Ensure the service entrance conductors and the main overcurrent protection device are adequately sized for the calculated load. Properly ground the new service in accordance with NEC requirements. This typically involves driving ground rods and connecting them to the service entrance. Use appropriate connectors and fittings for all electrical connections. This ensures secure and reliable connections. Label all circuits in the electrical panel clearly and accurately. This helps with future troubleshooting and maintenance. Use a torque screwdriver or wrench to tighten all electrical connections to the manufacturer's specified torque. This prevents loose connections and potential overheating. Inspect the grounding electrode system to ensure it is intact and effective. A properly grounded system provides a path for fault current and helps protect against electrical shock. Consider installing surge protection devices at the service entrance. Surge protection helps protect against voltage surges and spikes. Document the entire service upgrade process, including photographs and detailed notes. This documentation can be helpful for future reference. Comply with all applicable codes and regulations throughout the service upgrade process. This includes the NEC local building codes and utility requirements. Use appropriate personal protective equipment, PPE, such as safety glasses and gloves, when working on electrical systems. Always de-energize circuits before working on them. Use a voltage tester to verify that the circuit is de-energized. Follow lockout-tagout procedures to prevent accidental energization of circuits. Be aware of potential hazards, such as exposed wiring and energized equipment. Never work alone on electrical systems. Have someone nearby who can assist in case of an emergency. If you are not comfortable working on electrical systems, hire a qualified electrician. Electricity can be dangerous, and it is important to take safety precautions. After completing the service upgrade, test all circuits and appliances to ensure they are working properly. Provide the homeowner with a copy of the electrical panel schedule and any other relevant documentation. Explain the operation of the new electrical system to the homeowner. Answer any questions the homeowner may have about the service upgrade. Follow up with the homeowner after the service upgrade to ensure they are satisfied with the work. Address any issues or concerns promptly. Maintain a professional relationship with the homeowner throughout the service upgrade process. Communicate clearly and effectively. Be respectful of the homeowner's property and privacy. Clean up the work area after completing the service upgrade. Leave the property in the same condition as it was before the work began. Dispose of any waste materials properly. Recycle any materials that can be recycled. Promote energy efficiency when discussing the service upgrade with the homeowner. Suggest energy efficient lighting and appliances. Explain the benefits of using energy efficient products. Offer to perform an energy audit to identify potential energy savings. Provide the homeowner with information about energy efficiency programs and incentives. Consider the environmental impact of the service upgrade. Use environmentally friendly materials and practices whenever possible. Minimize waste and pollution. Conserve energy and water. Protect natural resources. Be a responsible steward of the environment. When selecting electrical equipment, choose products that are energy efficient and environmentally friendly. Look for products that are ENERGY STAR certified. Consider the life cycle costs of electrical equipment. Choose products that are durable and long-lasting. Properly maintain electrical equipment to extend its life. This includes cleaning, lubricating, and inspecting equipment regularly. Repair or replace damaged electrical equipment promptly. This prevents further damage and ensures safety. Upgrade electrical equipment as needed to improve energy efficiency and safety. Consider the cost of downtime when selecting electrical equipment. Choose products that are reliable and easy to maintain. Have a backup plan in place in case of equipment failure. This minimizes downtime and disruption. When planning a service upgrade, consider the future electrical needs of the property. Plan for potential expansion and increased electrical loads. Install conduit and wiring for future circuits. This makes it easier to add new circuits in the future. Consider the aesthetics of the service upgrade. Choose equipment that is visually appealing and blends in with the surroundings. Install wiring and conduit in a neat and organized manner. Hide wiring and conduit whenever possible. Consult with an architect or designer to ensure the service upgrade is aesthetically pleasing. Ensure the service upgrade complies with all applicable codes and regulations. This includes the NEC local building codes and utility requirements. Obtain all necessary permits before starting work. Have the service upgrade inspected by a qualified inspector. Address any deficiencies identified during the inspection promptly. Document the entire service upgrade process, including permits, inspections, and test results. This documentation can be helpful for future reference. Maintain accurate records of all electrical work performed. This helps with troubleshooting and maintenance. Keep a copy of the electrical panel schedule readily available. This makes it easier to identify circuits and locate breakers. Provide the homeowner with a copy of all relevant documentation. This includes permits, inspections, test results, and the electrical panel schedule. When troubleshooting electrical problems, start by checking the breakers and fuses. Look for tripped breakers or blown fuses. Reset tripped breakers or replace blown fuses with the correct size. If a breaker trips repeatedly or a fuse blows repeatedly, there may be a short circuit or overload. Investigate the cause of the problem and correct it. Use a voltage tester to check for voltage at outlets and switches. If there is no voltage, there may be a problem with the wiring or the circuit breaker. Consult with a qualified electrician to diagnose and repair electrical problems. Electricity can be dangerous, and it is important to take safety precautions. Never attempt to repair electrical equipment unless you are qualified to do so. Always de-energize circuits before working on them. Use appropriate personal protective equipment, PPE, such as safety glasses and gloves, when working on electrical systems. Follow lockout-tagout procedures to prevent accidental energization of circuits. Be aware of potential hazards, such as exposed wiring and energized equipment. Never work alone on electrical systems. Have someone nearby who can assist in case of an emergency. If you are not comfortable working on electrical systems, hire a qualified electrician. Electricity can be dangerous, and it is important to take safety precautions. Regularly inspect electrical equipment for damage or wear. Look for cracked or frayed wiring, loose connections, and damaged insulation. Replace damaged electrical equipment promptly. This prevents further damage and ensures safety. Keep electrical equipment clean and dry. Dust and moisture can cause electrical problems. Avoid overloading electrical circuits. Do not plug too many appliances into one outlet. Use power strips with surge protection to protect against voltage surges and spikes. Unplug electrical appliances when they are not in use. This saves energy and reduces the risk of electrical fires. Keep electrical cords and wires away from heat and water. Heat and water can damage electrical cords and wires. Do not run electrical cords under rugs or furniture. This can damage the cords and create a fire hazard. Use ground fault circuit interrupters, GFCIs, in bathrooms, kitchens, and other wet locations. GFCIs protect against electrical shock. Test GFCIs regularly to ensure they are working properly. Install smoke detectors in every bedroom and on every level of the home. Test smoke detectors monthly to ensure they are working properly. Replace smoke detector batteries annually or as needed. Have a fire extinguisher readily available in case of an electrical fire. Know how to use a fire extinguisher properly. Develop a fire escape plan and practice it regularly. Teach children about electrical safety. Supervise children when they are around electrical equipment. Keep electrical outlets covered when they are not in use. Use child-resistant electrical outlets. Teach children not to play with electrical cords or wires. Call 911 in case of an electrical emergency. Be prepared to provide the address and the description of the emergency. Stay away from downed power lines. Report downed power lines to the utility company immediately. If someone is being shocked, do not touch them. Use a non-conductive object, such as a wooden broom handle, to separate the person from the electrical source. Call 911 immediately. Learn basic first aid for electrical shock. Be prepared to provide CPR if necessary. Take a first aid and CPR course to learn these skills. Knowing what to do in an electrical emergency can save a life. By following these safety tips, you can help prevent electrical accidents and injuries. Remember, electricity is a powerful force that should be respected. Always take safety precautions when working with electricity. If you are not comfortable working on electrical systems, hire a qualified electrician. Your safety is worth it.